Welcome to Unit 5, Dilation Notes. So we have some vocabulary, so look at your vocabulary sheet for each one of the definitions of these words. So let's go ahead and take a look at number 1. It says identify the dilation to find scale factors. So dilation is connected to transformations. This one is not rigid. It's going to change the size of the figure. So we want to determine whether the dilation from triangle ABC to triangle DEF is an enlargement or a reduction, and then we want to find the scale factor. So enlargement means it makes it bigger, while a reduction means it makes it smaller. And if we look at it, we notice that triangle ABC to triangle DEF is getting smaller, so it's going to be a reduction. So will be a reduction. And since it's a reduction, that means that the number or the scale factor that we're multiplying by is going to be less than 1. So we need two corresponding sides. So same side on the figure. So if we look here, we have side AB on our first figure, and then on our second figure, we have DE. So these are known as corresponding sides. They're not the smallest side, they're not the largest side, but they're right there in the middle. So that's how we know they're the corresponding side. So we're going to use these side lengths to help us figure out what is the scale factor. So triangle DEF, the side length of DE is going to be 2. While the side length of triangle ABC, that AB side, is going to be 6. But we can reduce this down to 1/3. So the amount that we're reducing, the scale factor that we're multiplying by is 1/3. And if we look at it, that is less than 1. So that does make sense. So let's take a look at number 2. We're going to find and use a scale factor. So we got a school banner for the wheelchair tennis team that's based on this simple design. So it's a 6-inch by 14-inch design. Well, we want to enlarge this design. So that means we're going to make it bigger. So the number we're going to multiply by is a number greater than 1. How much do we want to make it bigger? We want to make it 5 times bigger than the original size. So that means our scale factor for this is 5. So that means this figure is going to be 500 times larger than what our original figure is. So what is the width of our original figure? Well, that's 6 inches times our scale factor, which is 5. So it's going to become 30 inches. Our length is 14 inches. So we're going to multiply that by 5, and that's going to give us 70 inches. So our new banner is going to be 30 inches by 70 inches. And this often happens in the world. You draw a smaller version of it, and then you make it a larger version. So we got dilations of a coordinate plane. So we're going to take a look at some coordinates just like we looked at last week. So a dilation is a function in which the coordinates of the vertices of the figure are multiplied by the same ratio k. So whatever we have of our original figure, we're going to multiply it by each of our coordinates by k, and that's going to either make the figure larger or it's going to make it smaller. In this case, our k was 3, so it made the figure larger by 300%. So let's take a look at an example. So triangle TRS has vertices T, R, and S. Find the coordinates of the vertices of T prime, R prime, S prime after the dilation of TRS by a scale factor of 1/2. Since this is a scale factor of 1/2, that means that it's going to get smaller. So whatever our original figures are over here, we're going to take half of those. So our k value for this is 1/2. So I have my original x and y. So we have t, which is -4, -5. We have r, which is 0, 6. And we have s, which is 4, 3. And then we're going to do the dilation, and it's going to be k times x, and we know k is 1/2, and then k times y. So come over here, t becomes t prime, because t is the preimage, t prime is the image. So we're going to have -4, or no, let's change the order of this. This is going to be 1/2 times -4, keeping with what we have up here. And then we have 1/2 times -5. Well, half of 4, that's going to be -2. Half of -5 is -2.5. R, let's do the dilation. R becomes R prime. So we're going to do 1/2 of 0. That should be easy. And then 1/2 of 6. Well, R prime becomes 1/2 of 0 is just 0. 1/2 of 6 is going to be 3. And then lastly, S goes to S prime. This is going to be 1/2 of 4 and 1/2 of 3. So S prime becomes half of 4 is 2 and half of 3 is 1.5. So here are our new coordinates after we've done a dilation of 1/2. So we've reduced the size of our figure by 1/2. Let's take a look at our next example, example 4. So we want to find the scale factor of the dilation. So on example 3, they gave us what the dilation is. Now we want to find the dilation. So we need to compare the lengths of the corresponding sides. So we have side CB prime, and we have CB of the original. We have C prime A prime, we have CA, and then we have B prime A prime, and that's BA. So let's just take one of the sides. So we're going to take AB and A prime, B prime. And we're going to use the distance formula to help us figure these out. Well, the endpoints of A are -3, 0. B is going to be 0, 2. A prime, its endpoint is -9, 0. B prime, its endpoint is 0, 6. Now you can use the other sides. We're just using these two sides. So again, we want to find the length of these. So to find the length of these, we're going to use the distance formula. So use distance formula. So let's do it for AB. This is going to become, so we're going to start off with 0 minus -3 squared plus 2 minus 0 squared. Well, that becomes 3 squared plus 2 squared, which is 9 plus 4, which is the square root of 13. Now let's find A prime, B prime. So again, same thing, 0 minus -9. 0 minus negative 9 squared plus 6 minus 0 squared. So this gives us 9 squared plus 6 squared, which is 81 plus 36, which is 117. So we want to find our scale factor. So we're going to go A prime, B prime over A, B. Well, A prime, B prime's length is the square root of 117. AB's length is the square root of 13. But we don't have to keep these square roots separate. We can put them together. So this can become the square root of 117 over 13, because it's just saying take the square root of both of those. Okay, we're going to do that. But when I do this, I notice that I can divide 117 by 13, just because I typed it in the calculator to see if I could, and I was able to, and I got out 9. So it doesn't hurt sometimes just to type it in. If you get out a number that's not a whole number, then don't worry about it. If you get out a whole number like I did here, 9, 9's not only a whole number, it's also a perfect square. So I could take the square root of 9 and I end up getting 3. So my scale factor for this problem is 3. So this unit is all about dilation. So when we look at it, we're trying to figure out, do we have similar results when we look at the scale factors for them? So we can either use the scale factor or we can find the scale factor. So go ahead and write a summary at the bottom down here, and then you're going to use these notes to help you out with the practice today.